welcome to the session. So, as introduced, my name is James Horne. I am a consulting engineer, I suppose, these days. I've worked in the industry for around 10 years now, starting out in more of an enterprise background at O2 Networks quite a while ago, and have essentially been consulting. Thank you. Essentially been consulting and contracting ever since. Joining AARNet about a year ago, my specialisations are really around network consulting, design and architecture specifically. And today I'll be talking about some of the ideas that we think, and I think more so, are the sort of direction of what we'll see in the campus network going forward. So just a little bit about my group at AARNet. I promise this is the only time I'll do this, but enterprise services are the consulting arm of AARNet, as Chris Hancock mentioned earlier today. A lot of people think of AARNet as just the pipes, but we're a newer part of the business, and we're aiming to provide independent consulting and advice, implementation assistance, and of course managed services going forward. So feel free to speak to James Sankar, our director, about any interest or requirements that you may have. And now that I've got the obligatory advert out of the way, we'll move on. So future campus design. Lots of animation apparently in the presentation pack. I want to start off by just giving a very brief overview of where I want to go. So just talk about some of the common pressures and trends that are driven by those pressures that we regularly hear about in our consulting work and our engineering work. I want to talk about the idea of using the campus network as a platform, and just very briefly touch on sort of unexpected parallelization of the campus network for research, and just speak very briefly about the idea of using some older service provider style technologies in the campus, or inter-campus, sorry, in order to enhance the bandwidth and throughput that we have around the campus. So the common pressures. So none of this will be really news to anyone, but there's been great pressure over the last 5 to 10 years to start moving DCs off-site for general corporate use. There's a lot of good reasons for that, as we all know: cost, complexity, high replacement cost, etc. Workload mobility, so that might be putting things in Amazon, but it's also NCI and things like that. The fact that it's making more and more sense to pull sort of high performance compute just as much as it is general compute and storage in the cloud. Consistent policy and experience. So this is more of a business driver in terms of engagement and that kind of thing. It's at the point now where we have our smartphones, we expect a consistent experience through containerized applications, etc. There's a real push at the moment with SDN, etc., to have a more simple, at least at a functional level, simple network and a more flexible network that's a bit more agile. Device proliferation, a couple of people mentioned this already, so Internet of Things devices are coming online, wireless use is exploding, and of course cheaper, because, well, cheaper, always, every time. So in terms of lining some of these trends that we see up with those, excuse me, so the private and public cloud, the X as a service, software as a service, platform as a service, even network as a service, possibly in coming years. The workload mobility has really been met by DCI type technologies, sort of stretching layer 2 domains for VM portability, etc., high availability reasons usually. And unifying networks is really one of the big ones for that consistent experience. So making sure that if you're on the wireless, the wired network, the WAN, etc., we get a reliable, similar result every time. And again, access technology is changing for that device proliferation. So IoT devices don't necessarily use 802.11. Various sort of building management devices, all kinds of things are connecting to the network, and it's changing the way that access is provided. And really one thing I want to mention is just in terms of that cheaper argument, trying to centralise as much as possible has been really the flavour of the last sort of 10 years. just trying to make sure that, our compute is virtualized, our storage is, centrally located, so on and so forth. And that obviously spreads to the network with more virtualization of network assets, whether they be virtual routers, VLANs even, that sort of stuff. It's a long story. So what I want to talk about in terms of the next bunch of slides is something that ideally would solve or aim to solve some of these concerns that are still highlighted here. So that unification of networks, automation and SDN, which I mentioned before, broadening that access layer definition and how it's sort of connected together, and talk about centralization in the same sort of sense. So the network as a platform. So I'll rush through these slides because there's a few network engineers here, I would think. So there's sort of a few evolutions of the typical campus network. You'll notice the cut from cisco.com graphics here. But essentially, the traditional bigger campus design was to have your layer 3 complexity at the distribution layer, spanning tree, all that good stuff. Some of the ways around that, which I know some of the customers we work use heavily, is VSS enable your Cisco gear, and then you have more use of your paths, your single logical links, get rid of spanning tree, etc. And then obviously the layer 3 access layer, we're moving the layer 3 point to the edge. The problems that still remain in these designs as we sort of progress through them, whether they're the VSS enabled, layer 3 access, combination of those, it's still relatively inflexible. It's still hard to change things quickly, to move things around. And one of the main things that I want to talk about is that routing inflexibility due to the way that the IP protocol itself works. When you route towards a host, there's that location information encoded as part of that address, and that is tied to usually a physical location, more or less. And if it is spread, it's usually spread in a fairly ugly way that performance, etc., doesn't really go so well. The client mobility piece is the other end of it. So in the data center, we've started to deal with the routing inflexibility problem for applications, and we deal with that by having essentially large high-speed layer 2 networks or emulated layer 2 networks in various ways. But in the campus, quite often, if you're plugged in at your desk and then you went and plugged in another building, well, you're definitely going to get a new IP. You don't get a consistent experience in that sense. And that obviously results in a bit of an issue trying to apply policy consistently as people move through the network, wireless, wired, etc. So this idea of the network as a platform. So this slide's back again, but really just for the purpose of explaining that it's not something that we want to do, change the way that we develop these networks. Obviously, there's a lot still in production. A lot of the skills that we have are really good, really efficient, high-speed layer 3 networks. Great multipathing, great failure from redundancy, high performance, all that sort of stuff. But the idea that I think will become more and more common is to use this network in the most basic, repeatable, reliable sense as possible to deliver it as an underlay service, as a platform for essentially having virtual networks overlaid over the top of that. And of course, there's a lot of advantages in doing this for a number of reasons, but one of them that you may like is the fact that once you've got one, well, you can have 2, or you can have 10, or you can have 1 million. Now, traditionally, this stuff was delivered, and some of the unis here have certainly done this, so they've implemented things, service provider style technologies like MPLS within their network core, or VPLS even in some cases. VRF Lite, hop by hop type technologies, maybe EVN in the rare case to try and simplify the configuration of that stuff. GRE, MGRE, that sort of stuff, which are really WAN technologies originally, and they've sort of been repurposed. But they often require special hardware and certainly a very special set of skills. I don't think changing skills is going to be a problem that's going to go away, but realistically, there's still a high cost to running these networks when it's not your core business like it would be for an AARNet. Looking forward, I think these overlay technologies, if they can make it into the campus in a useful way, would be the more likely, more manageable, more software controllable option to this sort of stuff. And I'm specifically going to talk about VXLAN and LISP, but obviously, EVPN and there's other methods. In the interest of time, I'll keep it fairly high level in terms of how it functions. Yeah, let's start with an overview of LISP. So some info on the slide here, which I'm not going to go through in too much detail, but the important part to understand about LISP is that it's a protocol that's been developed in order to attempt to separate that location and ID information within the addresses that we use in the IP stack, essentially abstracting those two pieces of information in a way that means we can route across other networks. It's essentially an encapsulation in that way, and provide a bit more scalability in terms of routing and prefix mobility. One of the main goals of it is to avoid having to change the way that the client itself operates, that the applications themselves operate. It's designed in a way that will stop that reconfiguration of every host on your network just to get this business benefit. To talk about a little bit, and we'll see if we can get the laser pointer working. Just again, a really high overview of how this works. So this diagram here is fairly simple, as you can see, so we'll keep it very high level. But you've got your two subnets here with different hosts. As you can see from the way this diagram is laid out, the idea is that there's an an underlay IP network, which is how we would use the campus in my suggestion. And this RLOC idea, routing locator, becomes the important piece of information about how to get from one to the other. Now, what that means is this particular local LAN segment that in every other sense is treated just like a normal LAN segment from a routing and client perspective, when this segment itself gets relocated, maybe to another data center for redundancy reasons, in the traditional example, it moves from here to here, but the clients are unaffected, and anyone routing back and forward to those clients are also unaffected. There's a number of ways that's done, involving various classes of tunneling routers, and that basically means that it also makes it a good transitioning mechanism, because this can run IP6 networks that are in their own segments across IP4 networks. It can be used in a WAN sense to deal with multi-site operation. It can also be used in a WAN sense to sort of best BGP in terms of load balancing. To be honest, it can very evenly weight the performance of dual internet links, even across providers, which obviously with BGP is a very difficult thing to do. I'm sure many of you have dealt with those problems in the past. Just the other technology mentioned is VXLAN. So VXLAN is a technology that has been developed in the data center. It's developed by really a consortium of three major network vendors initially, and it's essentially a very nice way of expanding the layer 2 domain, and really was targeted at the data center again. So, VMware is a major player with this particular technology. They use it very heavily in their NSX network overlay technology, for example. It's a good technology for, again, sort of DR style site redundancy and things like that, where VMs can be moved around and they still exist within, the same layer 2 domain as far as they know. That they don't know they're in the matrix. It's very expandable, very large amount of ID information in the header for VXLAN, so 16 million potential VLANs in theory. Generally what you see with some of the implementations is that some of that gets eaten into for other IDs or pieces of information within that part of the frame. But one of the important things is that it really does support a traditional LAN segment style operation. So broadcast, unicast, multicast is all taken care of, which is often a problem with some of the other encapsulation technologies that we've had over the years. The good thing about VXLAN is it has a really good wide vendor support now. It's gotten to the point where most of, I think, Juniper, Arista, et cetera, they're all really supporting the hardware VTAP endpoints sort of stuff, so that we can deliver this stuff very reliably at high speed in the data center. So to go back to this idea, in this case, what we can do by combining these technologies. So if we swap these around here at the bottom, you'll notice now that this particular host and this particular host are swapped around, and you'll notice that they're also in the same LAN segment with different information. They have different default gateways that they had before, and they're geographically isolated from one another. These routers here act as LISP routers, and they speak to a mapping service, which you may have seen on the slide earlier, is sort of like a DNS, I suppose, for the addressing. And it provides a quick and accurate way to replicate locational information. So it says this particular host now is at rlock 10.100.1.1, and that header that gets put together is addressed there, and then that local router worries about the actual host at the end. So yeah, to give you the example there, with the combination of the technologies, the segment is maintained by the VXLAN idea, but the VXLAN itself, that encapsulation is routed very efficiently through the network with LISP if you want to emulate layer 2 stuff, and LISP on its own with layer 3. It depends on how you want to set it all up. But what it means is that this host here geographically could still talk to its original default gateway. It also means that realistically hosts in the same segment can still continue to communicate with each other, even though they're again in separate physical or routing locations. So the technologies that sort of stack up with this, the edge layer 2 network is still your VLAN sort of type infrastructure. VRF can be referenced actually within LISP directly with an instance ID, so that can be carried throughout your whole network, dropped off at a WAN edge that doesn't support this stuff or that you don't want to for whatever reason. So it's quite flexible and can be really pushed back to the level where an 802.1x VLAN ID might be how the client's port gets configured, but the network adapts to that configuration based on its automated config and mapping of these different hosts. So just to bring it back to some of those trends, and I sort of mentioned that they were trying to address some of these. So the unifying networks part. So obviously you've seen the fact that we can have these two hosts that are now in separate routing domains and they're still communicating with each other as they were before. So that unifies the way that they talk to each other. Those two users in that same VLAN now can always talk to each other. It also means that you've got a unified policy maybe on the exit point of that particular routing domain. It means that you can carry that information really easily across the WAN. In fact, this technology can be used as an inter-site technology, as I said earlier. And it means that from the end station, whether they're on a wireless controller that's terminating them into that same VLAN at that particular layer of the network, all the way through to the data center and to the network border, it's essentially a consistent experience, a consistent routing environment. And it also means really the key mobility issue here, it means that the IP address of the host doesn't necessarily need to change every time they move between sites, between locations of any kind in a routing sense. Now, obviously, that has to be balanced against performance, it has to be balanced against all kinds of requirements, but with the technology that separates these two pieces of information in the address, it gives you a really huge amount of power in how you deliver these things. Again, the automation and SDN stuff. So automating things like MPLS, David White will tell you, Warwick Mitchell will tell you, that it really comes down to a bunch of scripts and getting the policies right and getting that stuff to work really well and reliably. It's important because to do it safely, especially in a BGP or an MPLS sense, is difficult. But within this sort of environment, again, you can bring it back down to potentially just a VLAN ID that's tied to your LDAP or your radius or whatever else. So it helps at that level too by simplifying the sort of reach of what's needed in automation. Broadening the access layer, that goes back again to what I was saying about you can have a wireless controller, terminating in this particular segment right here on this router, or a router up here, or a router over in the data center here, or whatever. That stuff means that you can connect all kinds of access types into these same Ethernet style domains. And then again, centralization. If you can provide a much simpler way of applying policy in a single space for each user type, etc., it's certainly going to help your ability to automate and centralize your management of these networks. And we all know, as engineers particularly, that we're asked to do more every year with less, and it gets more complex every day, what we're trying to achieve. So this is a way to sort of perhaps put some complexity into the under-the-hood network, but really provide a functionally simple response for as far as the business as an application delivery and the user as a client on the network are concerned. One thing worth talking about again is the vendor support. So VXLAN is really well supported, as I said. There's some of the vendors listed there that are really really putting energy into support for this stuff, particularly in the data center. Cisco particularly now have access sort of layer technology that's quite capable of this stuff. Huawei, I think Alcatel as well are doing basic things with this. So it's really well utilised, and particularly because it's such a strong, useful data centre use case. The vendor support for LISP. So LISP has sort of been a Cisco-driven endeavour, really. And again, I mentioned at the start that you could be talking about eVPN or a number of things. I chose to talk about LISP today because I believe it's an efficient way of doing this stuff. But being a little bit Cisco-driven, it means that other vendors aren't so interested in getting it off the ground, and it's still classified as an experimental RFC, as far as I'm aware. So that's. I'll get away from that now. I've just got a couple more quick slides about another trend that we're seeing going into the future in the campus networks. And as I mentioned at my sort of overview at the start, the unexpected parallelization of the campus network. What we're seeing is, and from a number of universities, and Surgeon from UCID, is going to come up and speak next just to talk about what they're doing and why. We know that universities in Victoria are certainly finding this as well. The network has been centralised and centralised and centralised, and we're trying to get all the same traffic. Maybe it is separated by VRFs, maybe it is separated by VLANs, but they're all on the same wire. And what happens is the network either can't keep up at all, or if it does, it gets strangled. The corporate traffic gets killed by an 8-hour-long 10 gigabit per second transfer from a researcher to another device. Firewalls, essentially in this space, just completely slow things down. They basically make most of the science DMZ technology a wasted investment by essentially not being able to keep up with the amount of data that they're having to process. And there is a overwhelming opinion, especially among sort of out-of-sector or new-to-sector CIO sort of level resources that have a bit of a different approach to security than your typical e-research resource. And essentially most of the operating systems, the products, the systems that are in use, the instruments, the way that some of these people work is not necessarily meeting up with those security requirements and is a genuine concern. And some security resources, I know in the room even, sort of see some of these research networks as a bit of a back gate into their nice secure front end that you can sort of get around it because the researchers aren't that interested in keeping anyone away from the data they're trying to share. So what we're seeing is universities create completely parallel networks. So they've got their campus network, the corporate network they've developed over years, highly redundant, high performance, but not 100 gig a second performance. Not multi 10 gig, not 100 gig, and if it is, you're certainly going to be getting in everyone else's way. So that's one side of why they're doing it. The other side, again, is to avoid the security problem altogether by saying, look, it's not touching our corporate assets. It's in a VRF over here where it does meet the network, and the rest of the time it's on a separate wavelength or fibre. The last thing I'll talk about just very quickly is campus connectivity. So connectivity within the campus and in between campuses at a shorter distance, I suppose. One thing that we're finding as an organisation is that we have customers come to our IDG team and they say, oh, can you sell us another pair of fibre? We're out of capacity on this link. And we say, no, you're not. You could do CWDM there, you could do DWDM there, you could have incredible expansion of your capacity on that link, and we need the fibre. Why don't you guys invest in CWDM? Realistically, that could be relevant on the campus too, in some of the bigger universities that have single mode plant everywhere anyway. A lot of this technology is a bit more sort of reliable, cheaper, easier to access than it certainly once was when most people last really thought about it in those sorts of contexts. And if you have you know, near to campus sort of reasons for it, or within campus reasons to do this, can be a great way to parallelise the network as well, by having, you know, that 10 gig wavelength that's getting smashed, and having absolutely no impact at all on the other little beam of light going along next to it. So I'll leave that there, because Philip Coles from Cyros is going to talk about that a little bit in terms of what they're doing, mostly as an intersite technology, but just something to think about. In terms of my talk, that really completes things. As you can see, it's fairly high level in the scheme of things. We've got another few speakers and a wireless panel in this session, so in the interests of keeping things moving, by all means, come and talk to me about these ideas, particularly if you have problems with them. We like challenges, and I want to use this as an opportunity to find out if this sort of stuff is useful to the sector, if there are parties investigating this sort of thing already at this level. And thank you very much.